In this video, we will discuss root locus rule number 3. In the rule number 3, a point on the real axis lies on the root locus if the sum of the number of open loop poles and open loop zeros on the real axis to the if right hand side of this point is odd. So that means consider this diagram. For example, the number of, or else I'll explain with the diagram. So in this rule number 3, we are analyzing how many number of root locus branches are there, and how in this rule number 3 says how to identify the root locus branches. Out of n number of branches, how many number of root locus branches are there? We can identify by using rule number 3. That is, with the example I will explain. So consider this example: g of s h of s is equal to k into s plus 1 into s plus 4 divided by s into s plus 3 into s plus 5. Using rule number 3, find on which sections of real axis the root locus exists. So now we have to see the roots, which are all the poles and which are all the zeros. So I told that in the previous discussion, the numerator roots are called as zeros and it is denoted by z, and denominator roots are called as poles and it is identified or denoted by p. So the numerator uh, roots are s is equal to minus 1, s is equal to minus 4. These are all zeros. Denominator roots are s is equal to 0, s is equal to minus 3, s is equal to minus 5. Now we'll try to plot that one, first one. So first method is we have to plot that. In the xy plane or a real and imaginary axis, we have to write that one. We have to plot by using scale, proper scale we have to consider. And always while marking the zeros and poles in the s plane or in xy axis, the poles will be denoted by or marked by multiplication sign, cross sign, and zeros are marked by using circle symbol. Like poles are multiplication sign, zeros are zeros, like circles. Here, see the poles s is equal to 0, so we have to mark here s is equal to 0, and that is first pole, and it is marked by multiplication sign, and s is equal to minus 3, it is marked by multiplication sign here, and it is another pole is s is equal to 5 minus 5, it is marked here at minus 5, and zeros at minus 1 1 0 it is indicated by circle, and at minus 4 1 0 it is indicated by circle. So now we have to see which are all the branches are root locus branches, that is by using some point. See here, between 0 and 1, it is 0, between 0 and minus 1, okay, it is a pole and zeros. So we have to write one, we have to like we have to assume some point here, and rule number 3 says we have to check how many number of poles or zeros are there right hand side of this. So right hand side of this mark is, oh, how many poles are there? Only one, 0, so 0, so it is an odd number, right? So between 0 and minus 1 I have to mark one point, and then I have to check right hand side of this mark how many number of poles and zeros are there. So here only one pole, odd number. So this branch, that is between 0 and minus 1, is a root locus branch. Understood? Now between minus 1 and minus 3, okay, 0 and it is pole. Just mark one more point, that is they marked this one as P. And now you have to check right hand side of this point how many number of poles or zeros are there. So how many number of zeros? 1 0 and 1 pole. So together it is 2. So even number. So the point or a branch between minus 1 and minus 3 is not a root locus branch. So next we'll go to point Q, that is between minus 3 and minus 4. So it is a branch, right? So between minus 3 and minus 4 I have marked like this one Q, And now I have to check right hand side of this queue how many number of poles and zeros are there. It is one pole at minus 3, one pole at 0 and one 0 at minus 1. So together 3 roots. So it is odd number. So I can say that now my between minus 3 and minus 4 it is a root locus branch. You have tried by using thick line. So here also I have tried by using thick line. Root locus branches are indicated by thick line. So now I have to go to between minus 4 and minus 5. Just mark one point here between minus 4 and minus 5. I can check on right hand side of this point how many number of roots are there. It is together 0 and poles. So it is 1, 2, 3, 4. So odd numbers, right? So between minus 4 and minus 5, it is odd numbers are there right hand side of this. So this is not a root locus branch. Now go for after minus 5 also, that is point R it is. See, after minus 5 one pole. So you have to check how many number of poles and zeros are there. See, one pole at minus 5, one pole at minus 3 and one pole at 0. 3 poles and zeros at minus 4 and minus 1. So two zeros. So together 5. Odd number. So it is odd number. So I can say that the branch after minus 5 may be till infinity. It is a root locus branch. So I have to write by mark by using thick line. So understood how to identify number of root locus branches for the given problem. So in this way we can see the number of root locus branches. See, it is shown here. So I told between 0 and minus 1 it is root locus branch, and between minus 3 and minus 4 it is root locus branch, and after minus 5 it is root locus branch. And between minus 1 and minus 3 no root locus branch, here also no root locus branch. And see, right hand side there is no roots, so it is a non-root locus branch. Understood? One more example we will see. We will try to identify number of root locus branches that we will see in the, okay, we'll see g of s h of s is given. This are all the equation is given, and here number of root in the numerator is s is equal to minus 2, it is 0, and in the denominator it is s square, so two roots at s, and s square plus 2s plus 2 it is a complex root, and s is equal to minus 3 is the last one. So poles at 0 and 2 poles we have to consider 2, and another one is minus 1 plus or minus j and minus 3. So 0 is minus 2. So we have to plot that one here at, see, xy axis at 0, see two poles that is marked, see here two poles, okay, 0, and minus at another one is complex root, that is at minus 1 plus j, it is shown here minus 1 plus j, and another one minus 1 minus j, it is shown here, and another pole is or another 0, 0 is minus 2, see it is marked by using 0 minus 2, and another pole is at minus 3, it is marked here. So and now this way we have to mark. Now I have to check how which are all the root locus branches. You have to keep in mind that while writing root locus branches, we are not considering complex roots. So we are not considering complex roots to identify number of root locus branches. See, we'll check between 0 and minus 1 one here. You just take one point here, right hand side of this one, two roots are there at 0, so it is not a root locus branch. Between 0 and minus 2 it is not a root locus branch, and after minus 2 we have to check right hand side of this minus this point, we have to check how many number of root locus branches are there. So it is at 2 minus 2 1, and at 0 2 poles are there, so odd number. We should not consider this complex one. So the point between minus 2 and minus 3 is the root locus branch, right in thick line. After minus 3, so one take one point, and right hand side of this one how many roots are there, check. Should not consider this root complex root. See, one root at minus 3, one root at minus 2, and two roots at 0. So even number. So after minus 3 it is not a root locus branch. So keep in mind that while identifying root locus branches we are not considering branches.